Welcome to Containers from the Couch. I'm Justin, and with me today is Jimmy. How's it going, Jimmy?
Hello, how you doing?
And we have a special guest today, Jim. We got two Jimmy and Jim, and a Justin. So hopefully no confusion there. But welcome, Jim. How's it going?
Very good. Thank you, Justin. Thanks, Jimmy.
And today from the show, we are showing off Kyverno. And I think the biggest question everyone has, Jim, is what is Kyverno? What is the name from?
Yeah, no, good question. And Kyverno means to govern in Greek. So, as we were kind of looking at Kubernetes and policy management in general, thought it was a good fit because it provides governance, provides, the ability to secure, automate configurations, as we'll see.
Cool. I'm looking forward to it. And we have a ton of great questions and some demos to show everyone. So if you want to follow along too, the Kyverno.io is the site, which has all sorts of awesome docs and examples that you can follow as well. So it's going to be cool. I'm excited to learn more. I have not had a hands-on experience with Kyverno yet, so I have a lot of my own questions and my own ignorance around why and when I'm supposed to be doing policy inside of Kubernetes.
Right. Yeah, so just to kind of provide some context there. So Kubernetes obviously is extremely powerful in what it can do through its declarative configuration management, right? So typically when you're instructing Kubernetes, what you want, you're specifying a desired state, and then controllers in the background will reconcile the current state of the system with that desired state. So declarative configuration management is very powerful, but also leads to a model where you have a lot of fine-grained configuration. And very often in a single resource, like if you think about a pod or a deployment, parts of that configuration are what matters to developers. Other parts are what matters to operations, maybe other parts to security. So how do you kind of manage all of this at scale, right? And who does what? So that's where policies, we believe, come in and kind of help automate that at scale, become this contract between developers, security, and operations team, and kind of help again, not just with security where you can enforce and validate, but also automate where you can mutate and generate resources on the fly, just to make configuration management simpler.
So, I mean, to me, when I look at policy, and I've been working with it for a few years, but when I look at it, to me, it's like putting up guardrails and directing the behavior, and not necessarily just controlling, but directing, because it's actually an enabler for the folks working with your clusters to know where they can and cannot go. And without them having to do their own thing to try to match your requirements, you can match those requirements at the cluster level. So
Absolutely. Yeah, so just simplifying those aspects and removing some of the complexity, it's big value add.
And Mohammed's here asking about Argo and Jenkins. I think there's actually a misconception here about what Kyverno's doing and Argo and Jenkins might be solving for your cluster. Jim, you want to talk about that?
Yeah, absolutely. And let me actually show right in the documentation. I'll pull up the introduction section. So Kyverno at its core acts as an admission controller, right? So think about it as being part of the Kubernetes control plane. And every API request that flows through the Kubernetes control plane goes through the API server, goes through multiple phases, starting with authentication, then authorization, and then admission review, right? So Kubernetes is designed to be extensible, and you can plug in your own admission controllers, which is what Kyverno primarily functions as. There also is a CLI, which based on time, if we can demo, I'll showcase how you can use Kyverno outside of Kubernetes. And Kyverno also does background scans, right? So if you think about it, you have your build, you have phase, you have your deploy phase, and then you have your run phase. Kyverno can operate at all three, but its main use case tends to be admission controls.
okay, so where do you want to start? I guess we start from the beginning. How would we get Kyverno into the cluster?
Yeah, so let's do that, right? So let's actually show what this looks like when we're running. So if I go to the installation section of the docs, you'll see there's some Helm chart instructions, For this demo, I'm just going to copy and paste this one command line, which pulls down all the YAML configs. And what I'll do is I'm just going to use my local Minikube cluster for the demo, right? So it's just right now doesn't have anything running. No, it's just got the basic namespaces. And we'll go ahead and install Kyverno itself. So as you see, once Kyverno gets installed, it pulls down a number of different configurations, including there's a bunch of roles it configures. So there's fine-grained configuration. There's a security section in the docs, which explains what each one of these roles are doing. It also installs some webhooks, which is what tells the API server to contact Kyverno based on certain settings. And then it's creating some resources, custom resources for policies, policy reports. So one thing unique about Kyverno is both the policies as well as the policy reports are completely modeled in Kubernetes fashion using declarative configurations again. So you can describe them completely in YAML, makes it easy to manage through kubectl, customize, etc. Right? So
So quickly, could I, just like using explain for other things, I could explain the Kubernetes extensions now that you put in there?
absolutely. No, that's a great point, right? So if I do something like this, if I want to see what exactly in the policy spec, there's rules and there's preconditions, what does that do? It will kind of tell you, and it gives you a link to get to more info as well, right? So, and if you have the right Visual Studio plugins enabled, you'll get help directly in there as well, because this is all driven through OpenAPI v3 schemas. Yeah, so now that it's installed, let's try and check the logs of in the Kyverno namespace and just make sure everything's running, right? So what we see is Kyverno came up, it registered some webhooks again, and I'll explain a little bit more about how these webhooks function. But these are what tells the API server to forward certain requests to Kyverno. And then it also now it's saying everything's up and running, right? But at this point we have no policies installed because I went through the YAML and I just installed Kyverno itself. It's got a deployment. It's got a bunch of other configurations, and these are also documented here. So it creates all of this within the Kyverno namespace by default, but we have no policies running, right? So if we go back to now at this point, just to kind of showcase, and first of all, if we start looking at some basic use cases, why do we need something like Kyverno, right? So if one of my favorite, I guess, scary demos in Kubernetes is this one-liner, which I think I saw Duffy Cooley demonstrate in the KubeCon or some conference, where if you kind of look at what this is doing is it's running a simple image, but then it's doing an NS enter and kind of also elevating privileges for this pod, right? So if I run this, the interesting thing that should happen if it's allowed on my cluster, which in this case I have no policies or no guardrails in place, all I need is permissions to actually run a container in any namespace. And now I have access, and it put me into a bash shell based on what's allowed over here because we're running bin bash. And if I do an ls, it looks like I'm on at slash at a root file system, right? And if we go and kind of look at even var log, and let's try and see if we can get to var log containers. I see all of the containers running here, and now I can see their standard out. I can even go back, if I go to proc, I can see everything, all the processes running. So definitely not a good thing, not something you want to allow on your clusters, right? So, and this is just stock Kubernetes. If you install Kubernetes by default without pod security policies or any other, it sort of controls or like a policy engine like Kyverno, this is what the behavior you would get. So to solve this, we had PSPs or pod security policies in Kubernetes. Those, as a lot of you may know, got deprecated and are marked for removal in 1.25. And there is a built-in alternative coming called pod security admission, which will provide namespace level controls, but doesn't allow the same fine-grained controls that PSPs allowed, right?
Can you do you know why, or can you talk about why PSPs got deprecated, and like
yeah,
why isn't something like this built in? Like it seems like there's a big gap there.
right. So going in, and I'll actually show what these some of these standards look like. So one of the challenges with PSPs and with any implementation of pod security is how do you configure, how do you manage at scale, what are the defaults you want to allow, right? So PSPs had a powerful way of configuring them through RBAC as well as other mechanisms which are native to Kubernetes. But the challenge always was that you have controllers, third-party controllers, or things like deployments running pods. So the role that might create a deployment is not the same that's used as the role to execute a pod, right? So that was one challenge. The other problem was just allowing exceptions, and fine-grained configuration became a bit complex and challenging, and it never, as different security concerns emerge, it was not a good way to quickly address those gaps, right? So the interesting thing which came out of those discussions, and there were Kubernetes SIGs like SIGAuth, SIG Security, led this, is they're standardized on three levels of privileges within a cluster. So there's privilege, which allows everything. So typically you do not want to run applications at privileged mode. But then there's also baseline, which is gives you some minimum restrictions, and there's restricted. So the thought process was that now, just to make it easy to have some secure by default option, you can set up pod security admission, and you can mark a namespace as baseline or restricted. You can set baseline by default, so at least you get some security. But the other more restricted policies, which are in the restricted profile, you would have to configure yourself, right? So in essence, what we typically would recommend is to say you want to start with restricted by default, and then configure exceptions only when necessary. But to do that, and to kind of make that a default, just was deemed as very difficult, because there are some valid use cases where you might want to allow some pods to have privileges and things like that.
So I think one of the things that's glaring here is that, when we look at these policy engines, they can look at the inbound API server request flow, and they can look at that payload and see, and they can make decisions about allowed or disallowed based on items within that payload that are not necessarily exposed using the new PSA, PSS standards and tooling.
Right. Yeah, and the other challenge with using PSA is, of course, you want to get reporting else in a native manner, as well as you want to also, as you're kind of scaling usage, you may want to kind of allow this the configuration of exceptions, other things, again, in a very, like you were mentioning too, Jimmy, in a fine grained matter, as needed, right? So, and not just at the namespace level. So if you're running larger namespaces which include multiple controllers, it becomes difficult to you kind of have to sub namespace or use some other mechanisms, and you kind of now have a more namespaces to manage.
So at this point, we've got Kyverno installed. Can we
Yep.
see it in action, see what it does?
Yeah, so let's go ahead and apply, pod security policies, right? So, and I'm gonna apply just the default from here, and what you'll see is now, if I do, get I see a bunch of policies. I see they're in audit mode, right? So what just happened is, because they're in audit mode, and in a few seconds these will all go ready. So by the way, when they are ready, it means now Kyverno has updated the webhook to start receiving events for this policy. When these are in audit mode, let's say if Kyverno happens to be down or not reachable, the API server will still continue. But if I flip him to enforce mode, what's going to happen is it's going to, those will actually, requests will be blocked, right? So actually, let's do that. So I'm just going to change this customization, over here, and we'll reapply these policies. in enforce mode, right? So
it's very
'cause-
similar to like SE Linux, right? I could have a ability just to like, hey, I just need to know what would be a problem and what
right.
things, you know, and then later on I want to switch to actually enforcing and say like, hey, actually no, not allowed anymore.
Well, yeah, you bring up a good point. I think when you're introducing new policies in general to your clusters, it's a good idea to be able to understand the impact, right? So it's a great idea, the impact analysis, but there's other things, there's other reasons why you have these audit policies as well. Maybe we can talk about those in a few
Right.
minutes.
Yeah, so there might be, I mean, so certainly something like pod security you do want to enforce, but like best practices, which maybe just, good thing, good hygiene for your cluster, but maybe you don't want to enforce those, or you could choose maybe in your dev test of product cluster you audit, and then in your production clusters you enforce. So a lot of flexibility in terms of how you can manage this. But just, now if we show the same command again, right? We already have that pod running, by the way, but the same command, was blocked by Kyverno and shows a number of different violations, right? So everything from it's saying, we did a drop. It wants you to drop capabilities within the pod. Host namespaces are not allowed, so you can't, register a pod in there. Privilege escalation, disallowing again any container with privilege mode as root user, that's blocked, as well as requiring some seccomp configurations, right? So all of this is just, again, as you see, like in a few minutes, you can go from like 0 to fairly secure for your workloads. And in Kyverno policies, one thing I should have shown in the docs is there's a lot of flexibility in how policies and rules are organized. So you can match and exclude based on kinds, names, labels, namespaces, roles, usernames. Even you can look up things from the API server and have preconditions to filter rules. And then you can apply either verification or mutation validation of different resources, or you can generate resources on the fly, and we'll look at those use cases. But the goal here is, because now you can have these exclusions and exceptions, again, make it very simple to have fine grain control over how you're enforcing pod security, right? So just again, simple way of looking at this, and at admission controls, again, you will see this, and your insecure pods will get blocked right away. What I'll do next is I'm going to actually flip these back to audit mode. And the reason why I want to do that is I want to show what the reporting looks like, right? So let's go back to the customize command. And I'm just going to rerun it with, pod security. So that should flip it back into audit mode. We'll verify by looking at this. Yep, so all the policies are now in audit. And what I want to show is, if I look at, so CPOL, by the way, is a short form for cluster policy. So, and POLR, or POLR, is a short form for policy report, right? So like I said, both of these are, native resources. And if I do, so there's nothing and they are namespace too, which is nice because now developers can get the reports in their own, namespace if needed, right? So if I run, let's say, now that everything's in audit mode, I can just do something like, let's just run an nginx pod, and I'm not going to dry run it. I'll actually run it. And if the pod got created, now if I look at policy reports, immediately it's telling me that 15 rules passed, but 4 failed. So if I want to look at this further and see what exactly failed, um, let's look at it in YAML, and I can see exactly which rules failed. Now, it's telling me, again, these are all the pod security policies which we had just configured, and I can see which those fail. One other thing to quickly show here is, if I just, even if I want to create a deployment, so let's try that. We'll say create deployment, and I'm just going to dry run this so it doesn't create resources. And in this case, because we have them in audit mode, yeah, maybe dry run is not the best idea. We'll put them, I'll go ahead and create the resource. But what I should see now is there's more violations even for this new resource, even though I created a deployment, right? And this highlights one of the features in Kyverno where you can write policies at the pod level. And by default, Kyverno will automatically generate rules for standard controllers.
I,
And you can customize this as well.
I think that's exactly what Waleed was asking for here, as far as like reporting in comments about like, how do I, if my pods are being, hit with these policies or not complying to policies, like
Right.
how do I know what created that pod is actually difficult. Sometimes you have to find the deployment or a job or cron job or something like that, and bubbling that back up to like the top level thing is great, because then you can actually track down like, okay, who owns this, how did it get deployed here. That's a lot easier than starting at the pod.
Right. Yeah, and if you describe the pod, let's check that, one of the pods. And if I describe nginx, I'll also see that, in the events itself, Kyverno kind of inserted sort of any policy violations. So again, as a developer, if you're looking at your own workloads, you've deployed that, you can look at the policy report, and you can also see this within your pod itself. And so similarly, if you mutate things, if you change things, that will also show up both as an annotation, and there'll be an event to show that within the resource itself.
But there's a lot to be said though for being able to generate those workload policies by just writing physically a pod policy, because a lot of times we are deploying workloads, right, using deployments and jobs and daemon sets, and we're not strictly going in there and just building out a pod. And the user experience is better if I can immediately know at the client call that I've got an issue.
Right. So, yeah, makes it a lot simpler, and you don't have to then manage this for all the different controllers. And you can also, by the way, it supports custom controllers as long as they are following the same pattern that in the internal controllers use. You can have like Argo deployment or other kind of controllers as well. Yeah, so those are just some very basics, for getting pod security up and running, and monitoring and managing. There, by the way, there is also a graphical kind of tool, and I'll quickly show that because it's worth calling out. So if I go into reporting, I want to kind of quickly show you that you can also view your policy reports using this tool created in the community called Policy Reporter. So internally, the standard, the CRD that Kyverno uses is something that's being discussed in the policy working group. And it's being standardized by the policy working group, right? So the nice thing about that is now you can get policy reports from Kyverno, or you can get policy reports from other tools which support the same format, and you can show them in any tool, either in cluster like what we'll see over here, or if it's an external tool, it'll, like a management solution, you can also then see policy reports from Kyverno, as well as there's adapters already for Falco, kubearmor. There's also adapters for kubebench. So all of this can be seen in a very standard manner, right? So
And
just
that brings up a good question for me. Like, at what layer do I want these different tools, right? I mean, like if I want to use Falco, or I need Falco, like, do I also need Kyverno? Do I need something else? Like, how it's interesting that they all work together and great. But
right.
curious, like what the layers are there of just like, when do you need a different thing besides just policy?
Yeah, good question, right? So policy is, of course, a fairly general term. But here, so Kyverno does configuration policies, but Kyverno doesn't look at, runtime occurrences. Like, for example, if somebody, if someone execs into a container, that also goes to the API server. But let's take another example. If somebody, kind of is inside a container, and they're allowed, but then they try to mount a file system, things like that, which you can pick up through eBPF, right? So Falco and Cilium and kubearmor, they all kind of look at eBPF for runtime events, and they have the ability to kind of manage things, policies at that level. So Kyverno is more admission controls and configuration policies, whereas that class of tool is more runtime. So what we kind of advocate, at Nirmata is you're going to need both, right? But obviously you want to kind of enforce this as early as possible. You can't wait to runtime because it's already too late. I mean, you're detecting things rather than preventing things, right? So ideally, you're preventing things in the configuration, and there's a lot of best practices and things that can be applied there. But then runtime is another layer of security you can additionally add.
So to make sure I understand it, then I've got maybe SecComp in there or AppArmor to prevent unwanted, let's say, syscalls from user space, right down the kernel space, and then I've got Kyverno on top of that to prevent anything from entering into the cluster that would make those unwanted calls, right? And now I may also have Falco in place that's going to allow me forensics collection and look at what's actually happening in my runtime environment. So what I've got now is a defense in depth approach, right? Where Kyverno is blocking, the inbound, and then, but if anything gets past that for whatever reason, I've got other layers that I can rely upon for runtime forensics and security.
Absolutely. Yep. Yeah, so this tool, Policy Reporter, is picking up right now. We saw the kind of violations. We can see them in the different namespaces. Pretty slick tool, created by Frank Jogile, who's one of the Kyverno maintainers, and he manages and maintains this, which he has donated into the Kyverno project. But yeah, beyond Kyverno, it can also pick up policy reports from these other tools. So yeah, definitely check that out if you're looking for a simple way of like looking at this per namespace or across an entire cluster. Kyverno does also.
I'm sorry. So what about downstream? Like I've got a SIM that I want to put things into. Or like I know that I've been to a couple of the working group meetings, and it's there's talk about OSCAL integration, and I mean, can you speak about that real quickly? Or?
Yeah, so now that there's a emerging sort of standard for these policy reports and violations, I mean, all sorts of things can be built on top of that. So there's of course management solutions like OpenShift, the Red Hat Advanced Cluster Management, as well as Nirmata, my company, that provides like management plane tools for multi-cluster. There's also as well as governance and management of policies. And there's kind of other tools where you can the integrations can be to push things into other CM tools or even notification tools, etc. Right? So, and that can be done either from each cluster or centrally through a management policy administration point.
Okay, so what are you gonna show us next? I'm one of the things I'd want to see is, and I talked to you before this, generate policies, right?
Right. Yeah, so let's take a quick look at that, right? Because that's a very interesting and unique use case. So what I'm going to do is I'm just going to let's clean up some of these policies, and we'll kind of switch to the generate use case itself, right? So Kyverno, as it works as an admission controller, what it can do is in addition to validating, enforcing, you can have policies that look at different resources coming in. Like for example, if a namespace is created, Kyverno can look at that and either mutate, and in here it's like creating a standard label to say who created this namespace, right? Or you can also then generate things like, for example, you want to generate a default network policy, right? So you want to deny everything by default and then allow your dev team to maybe add specific network policy rules. Or you could do things like, if you have the right label on the namespace, using that to trigger creation of a central network policy like a Istio policy, right? So lots of interesting use cases around that. But what I'm going to showcase is just how can you do, like, multi-tenancy continues to be a big problem, right? And it's a topic I'm personally very interested in, and I kind of contribute also in the multi-tenancy working group in the community. So I'll showcase how do you do some lightweight multi-tenancy with Kyverno, right? So what I'll do is I'll
and just
yeah.
before we start, like the alternative here, or the way that a lot of people do it, is namespace creation is controlled by a team, right? Like a lot of times, like, hey, if we're going to share this cluster, that team over there is the one that they have to set up everything, because they have to make sure the tags are right. They're going to do all that stuff manually.
Yep.
And so in this case, you're saying, now let's just create a policy that automatically mutates anytime you want to create a namespace. And then we can make sure that those policies and everything else are there correctly. We're not going to be able to create a namespace, and you're freeing up the team to be able to do other things, and making sure that that is everywhere. Otherwise, it doesn't get created.
Exactly. Yeah, so you're in on these policies, you know, you can do some pretty interesting things, right? So just as a demo, what I'm doing here is I'm saying every namespace has to have a certain set of labels. And one of the labels is the type, which I've just created like small, medium, large, right? So let's say 3 t-shirt sizes. And it's up to me what I define those as being. So of course, based on application, you can customize this however you want. These are policies you're managing. But once I set this up, now I'm allowing, you know, self-service, and I have a couple of roles I created here, which I will include. And so there's Ned and Nancy. These are namespace admins that I want to allow them permission to create namespaces, right? But when they create a namespaces, I'm still applying policies and certain rules to restrict what they can do and to kind of guide and govern the behavior there, right? So that, like you said, it eliminates all that manual handoff, and that, you know, it also allows some standardization and automation. So what we've seen is, you know, teams just completely automate all of this through, you know, Git requests, so you can create a PR in a repo, which would trigger some automation to then create your namespace. So all of this is audited, recorded, but you now have your platform team setting up the policies, developers coming in and saying, hey, I create a PR to get my namespace. You know, once I'm done with it, I can delete that namespace. And it's just nice and simple and easy to manage. Yeah, so let's take a look at an action, right? I'm going to just apply this, and immediately it shows me, first of all, this is a good thing. You know, I should have pointed that out earlier, but Kyverno by default does not have permissions to create things like cluster roles, etc., right? But we do want to give it permissions to create fine-grained cluster roles. So it's telling me that, hey, there's this, you know, remember when we installed Kyverno, there were a bunch of, you know, roles and things which got created. And I said, if you look at the security docs, it'll tell you what each one of those are and how to manage them. So here, what I want to do is I want to edit this cluster role generate, right? And if I look at it by default, it's allowing some namespace level configurations, but it's not allowing, you know, in the RBAC thing, it's not allowing cluster, you know, roles and role bindings, right? Which is what we, in this case, we want to allow that. So let's try and give it those permissions. So I'm going to say cluster roles and cluster role bindings. And we'll save that and try this again, just to make sure we can go through now without any errors, right? So good. So everything got created. And if I now look at, you know, so by the way, that validation is custom validation in Kyverno, right? So it's just helpful that it tells you that when the policy is deployed, rather than troubleshooting, you know, later to say, why didn't something work, right? So at this point, if I create a namespace, right? So, and let's try and create this as a specific user. So we'll say create namespace test, and we'll say as, you know, let's say Nancy, right? So if I do this, oops, forgot my create. So we'll put that in and say, once I create this namespace, it's telling me right away that, hey, you know, Nancy's allowed to create the namespace, but we have this policy which says you need to tell me what type, right? And I'm not going to default the type, and you could default the type if you want, but in this case, I have not. So it's forcing, you know, giving a type. So to kind of, you know, manage that, what I have is, if I look at the resources, and there's you know, there's a namespace. So over here, so let's just quickly look at it. So this has a, you know, label, which is a simple namespace which just says the type is medium. So let's go ahead and, you know, apply that. So if I say kubectl, oops, And we'll do apply. And we want, this resource, and we want to do this as that user, right? Because of course, as an admin, the policies are configured so an admin can create namespaces, but users cannot. So if I create this as that user Nancy, now this time it went through because I met my requirements. And if I look at this namespace, so let's say as Nancy, I should be able to see the namespace, but if I look at it as Ned, it says I'm not allowed to see that namespace, right? So what Kyverno did behind the scenes and what I have in my policy is there were a couple of roles, fine-grained roles that Kyverno created, right? And I'll just quickly show what those look like because they're interesting. So it created a cluster role called namespace owner, and then it also created the namespace. Let me find the this is what I was looking at. So it generated the namespace owner role, and it's saying that only, so Nancy now has permissions to only view and delete that particular namespace, and other users like Ned did not. But and it also gave me permissions, to be able to go as a namespace admin to do things inside that namespace, right? So all of this got generated, and we also had a policy, to do this network policy, right? So let's quickly check on that. So if I say namespace, let's say get, we'll do minus n test, and we'll describe quota, or let's first start with network policy. Whoops. So looks like not allowed. So that permission, that rule would need to be added. But just to show, and this can be, it depends on how you want that, right? So if you don't want that, even the namespace owner to see the network policy, you can manage that. If you want the namespace owner to see that, because it's a generated resource, you can allow them to do that. But if I view it as an admin, I can see the network policy is created and everything is blocked by default, right? So now that user can create more network policies for their app to allow certain routes, but by default, it's secure and segmented based on this configuration, right? So again, simple way and a few set of policies. All of these, by the way, everything I'm demoing is in our sample library too. So if you go back to the Kyverno page and go up, let's go to the Kyverno.io, and if you click on policies, there's about, and these are all thanks to the community, we're almost close to 140 different samples. You can kind of browse through them based on the type of policy, as well as which resources they apply to. And more we're coming up with policies specific to different other open source communities and tools, as well as certain use cases. So if you have requests, if you have like ideas for policies, feel free to reach out on Slack or on the GitHub itself, and we can kind of showcase those.
So if I had we're talking about multi-tenancy here and locking down namespaces by default. But if I had a desire, let's say, to manage multi-tenancy in such a way that I'm on the same cluster, but I'm running my pods on my own set of compute, let's say tethered to a namespace, I could use generate policies to go out there and create the namespace, and actually go out there and create a set of, let's say, tolerations and node affinities that get applied to inbound workloads as they hit my namespace, right? I mean, I could create those, right?
Yep. Yes. So you can kind of target certain nodes based on either labels in the workload, labels in the namespace. You can, even, so you can inject node selectors. So there is, so either through taints and tolerations or node selectors. I think there's an example of that. So those are, all valid use cases. Yeah. So this will inject a node selector automatically based on other things in that configuration, right? So you could say if it has a certain label, go ahead and inject a names node selector, or if it's from a certain user, you could do it based on that as well.
And to be clear, it wouldn't be good enough to mutate the inbound requests. I'd also want to have a validation rule
Yes.
policy that would say, hey, based on this namespace, do I have the right tolerations and node affinities in place so that it, doesn't go into someone else's namespace?
Right.
There are a few
Yeah.
questions I wanted to bring up that were a little bit old now, but I wanted to still ask them.
Sure.
Is there a way to nest policies or have some sort of like priority between policies? Mohammed asking.
Yeah, so each policy itself, so policies contain rules. Rules are, executed in order, right, within a policy, but there's no ordering between, the policies itself. And that's by design because we want each policy to, be atomic and kind of fail or succeed in isolation from other policies. So you would not be able to override a policy somebody else has configured, but you would be able to, kind of, again, you can add exceptions into that policy, but you'd have to change that policy's definition.
Cool. And Waleed was asking about, Jimmy, we brought up earlier, like the layers of, do we want file code, do we want Kyverno and policies? I'm not exactly sure what Waleed's asking for, like which portions he wants to do earlier in the stack, but in registries, that's where you get like security scanning just to see like obvious vulnerabilities, known CVEs, that sort of stuff is where you're going to actually do some scanning in a registry itself and not necessarily in the Kubernetes cluster at all, because we can't detect necessarily what the image, I mean, I guess we could rip apart some of those image specs and see what they're going to do. If we know that like there's a host mount volume or something that like it tries to do, but it's all of that is runtime configuration, not build time configuration.
So for me, and I'm open to people disagreeing with me, but for me, it's a matter, when I say defense in depth, I also think about do what you're supposed to do in each one of those tiers, let's say. So, Kyverno has a CLI as well, right? So I could do some CLI work in the CI/CD portion of my, let's say, my quote unquote supply chain, and then when I get to the images, a registry is going to scan, it's going to encrypt, it's going to control how it's vended, and so that's where I'd scan my images. And then when I get my containers actually running, I would do runtime container security, which is where Kyverno sits at the front door, preventing unwanted behaviors. And but other tooling would also detect, drift or unwanted binaries. There's a lot of tools out there that are open source as well as from partners that can, so it's not a matter of either or, it's a matter of all of them together. And some of them may duplicate some of different layers, but I think that's the whole idea behind defense in depth.
Yeah, no, great explanation there, and certainly I think having the command line tools to run in CI/CD pipelines, being able to do this as early as possible is necessary. So one thing I wanted to showcase, though, and this is a great segue into supply chain security, so we can talk about what Kyverno can do with container image signing, with even attaching things like SBOMs or vulnerability scan reports. Lots of exciting things in that space. But before we go there, one interesting quick demo I'll do, right? So this policy is actually looking up the image config data. So it's going to the and so Kyverno can do external calls, but it's not designed to be an open system. It's for Kubernetes. So the way this works is there's built-in integrations to certain things like OCI registries, right? But those integrations, the idea is to make it super simple than to check for things like this policy is saying if an image was more than 6 months old, don't allow it, right? So I want to make sure that my images are kept current, and for certain workloads, I can enforce whatever period makes sense, right? So a year, 6 months, a month, etc.
And that's going to apply whenever I try to create an image or create a pod in the cluster, right? So if I had a deployment that sat there for 6 months that I never updated the image, but I need to then all of a sudden, if nothing's going to stop it from continually to run, but if it tried to scale out, it would fail. Right? The new pods would not be created because those are against policy, but the existing pods are fine.
So for the existing pods, it will show a policy violation, right? So you have that alert first off. And with 1.7, a feature is coming to mutate existing resources, which will actually let you scale down that workload if you want, right? So that completes exactly the scenario you were thinking of, where, but in most cases, you're not going to want to, tear down your production workloads. You're going to want to alert and say,
the importance of audit mode. That's
right. Yeah, so that's where the idea is that at least you can audit on it very easily, and once you audit on it, it's up to that team to kind of take the right action. Yeah.
So that
So,
the previous example you showed though, where it was looking for time since created, that's available from a generic OCI registry. It's not
yes,
like a
any
tag.
OCI registry. Yeah, so anything which can. So basically, and I'll show you what that config looks like. So if once I apply that policy, so let's say if I want to do kubectl and run nginx, if I do image latest, of course it'll be fine. But if I want to run, let's say if I remember the versions correctly, I think let's try 1.13. I know that's pretty old because nginx is probably at 1.21. We'll just do a dry run here because this policy, let me double check, but I'm pretty sure it's in enforce mode. Yeah, it's in enforce. So that way it doesn't create. So we'll say dry run equals server. Right, so we're just saying run nginx, do that. And what it's going to do is it's actually going to fetch that and it says, hey, this one's pretty old, don't use that. But if I recall correctly, 1.21 is more recent, which let's see if that works. Well, I already have an nginx, but it went through the webhook and it allowed that, right? So that's, and to do this, if you kind of see what exactly is it looking at. So if I go back over here, and if I just say, in Crane, I can kind of look at, Crane is a command line tool to kind of inspect OCI registries. So if I just look at nginx latest, there's a bunch of stuff that you can pull down and it shows me exactly how this image was. So let's actually make that a little bit prettier. Um, we'll pipe it to JQ and yeah, so there we go. So we see the layers, we see everything that was built. So you can even do things like, there's example policies to restrict volumes, right? So that's something you just mentioned. Justin, if you want to kind of now, let's see, I don't have that here, but it's in the, um, let's find it here. So you can kind of restrict things. You can even do things like resolve, image tags to digest. You can block, large images. This is the one for which blocks volumes. So all of this is now possible because this is how you built the image, right? And you're writing policies on those. So again, as a platform team, you have a, crazy amount of control in terms of what you want to allow and what you want to deny and how you want containers to be built. Like one of the questions we had in the community, which is an interesting one, is, hey, how do I prevent somebody from overriding a layer, right? So now you can check and see which layers were added, and if it's something which you want, in your base image to enforce and not to allow that to be overridden, you could write a policy to block that. Yeah, so that's just on the image config. But very quickly, I want to show also some policies which will allow you to do more than just check for config, right? So this policy is checking to make sure your image is signed, and Kyverno has a built-in integration with Sigstore's cosign. So Sigstore is another Linux Foundation community, and their focus is on supply chain security. So from Sigstore, there's a bunch of open source tools, cosign for image signing and verification. There's a tool called Recor, which is a transparency log to keep metadata and things. And then there's Fulcio, which is a web-based, identity management solution to offer what's known as keyless signing. So and this, by the way, says check image keyless. So just to explain what I'll do in this demo is if I go and look at the repo that I want to use, it's just a Java Tomcat repo. And if I look at the actions here, I've built a GitHub pipeline, which as part of that pipeline, it creates a scan report, it creates an SBOM using Cyclone DX format. So this is once the image is built. And then it's signing all of these using cosign, and it's putting image signatures. If I go and look at my registry here, I'll see that it has image signatures also attached to it, right? So I want to go look at all the versions, and I'll see that at least version 0.0013 has image signatures, but V1 does not, right? So let's apply this policy and see what happens, once we require that for our cluster. So I'll clear this screen, and if you look at that, what I want to do is we'll do check signatures. And now if I run Tomcat, and let's try V1 first, which should get blocked if everything works correctly, which it did. So it immediately said that, hey, there's a signature, failure because there's no signature on that image, right? But if we kind of go back to, I think it was 0013. If we do that, oh, it
I think
it
you need the
didn't
V.
find. Oh, right, the V. So that should now get allowed because that image is signed, right? So very kind of simple, quick demo, but shows the power of, signing images is another, looking at defense in depth and security best practices. This is quickly becoming something that, is highly recommended. And it's very simple to do with cosign and SigStore as well as enforce with Kyverno.
So it's doing two things here, right? It's verifying that a signature exists, and then it's also checking in against a certificate, or
Yes. So
nice.
it's checking and it's ensuring that it matches. So in this case, just to explain a little bit more about how I had my repo set up. So what I used, in fact, in my action here, if I go into one of this, is what's known as that keyless signing, right? So what that means is I'm creating my scans, my SBOMs, and you can create other metadata as well. But here, when we're signing the image, I did not give it an identity. But what I'm telling it to do is to say use the feature of generating an OIDC identity to be able to sign that image. And that's where so when I'm verifying it, I'm using my root certificate for my for Fulcio to say anything signed by that is allowed, but I'm also going to check for additional metadata, right? So looking at a more complex example of the policy, you can do things like you can check and see, hey, I want to make sure that this image has an SBOM and it has to be in cyclone format, or it has a scan, in this case from Trivi, right? Or I can check and make sure that I have a certain score, no vulnerabilities allow higher than 8 in if I'm using something like Vex format, or in this case again I'm using Trivi, but you can customize this as needed, right? You can also
That's real,
check for other provenance data like who built this, which branch, things like that.
that's really neat to see the integration there with a registry scanner, because historically it was always like, okay, we set up scanning on the images and
Right.
then we just trust someone else that verified the reports, right? Or said,
Yeah.
or reported on it, like saying like, hey, by the way, like you have a critical, a 10 CVE, like maybe don't deploy that. But there's no actual enforcement there. It was always just like kind of emails and back and forth between people of saying like, hey, I checked this report, here's what it said, you need to go fix it. And now you can enforce that directly at the don't create this thing unless it's past these checks.
Right. And by the way, if what we recommend is that your scan reports are updated like daily or weekly or some frequency that makes sense to your organization. And you can do all of this now. So previously there were some attempts at doing this in cluster, which doesn't scale very well, right? And then you have to rely on every cluster to be working, and there's just more points of failure. So ideally you would still run this as a cron job outside of the cluster. But once those scan reports are refreshed, you can then verify inside the cluster, even flag workloads which are out of compliance. Or you can do things like, hey, I want to find any package, using my SBOM, any use of things like log4j, right? Just to go piggyback on a popular example right now. Those are It's all possible once you have this metadata attached in your
Yeah,
image registry.
that's really cool.
Yeah. Yeah, so several use cases around that, and I know we won't have time to go much deeper into that with attestations, etc. But very quickly, one more thing I want to show is how you can, also do things like Jimmy mentioned outside of the cluster using the Kyverno kubectl plugin and the CLI, right? So a couple of use cases we see there. First of all, just applying policies, right? So if I want to apply, so here I have a simple policy which is saying I don't want to allow the use of latest tag, right? So if I say, kubectl, and let's say kubectl Kyverno, and we'll go with apply this thing. So first of, by the way, I can apply it on a cluster. So if I do minus minus cluster, it's just going to use my kubeconfig, and it's showing me that policy applied on every matching resource in my cluster, right? So extremely powerful way of testing a policy. Or you can just apply it on a resource if I don't want to apply it on my cluster. And I say, this is the pod YAML here. So it's showing me that, by the way, it's 4 because of the auto-generated rules. But, it has one pass, one fail, which is what, it would expect, this pod, there's an error in here because it is using latest, which is why it's getting flagged, right? I can also, a similar command here is if you do kubectl, if you're writing policies and you want to write test cases for it, let me switch to the right directory here. So I'll go and show an example of how we test things within the Kyverno projects itself. So let's run the plugin. And if you do test, it will show me all of my policies applied to different resources. So you could have success cases, failure cases, and it shows me how many tests were applied and the unit tests kind of for this, right? Because it's important as you're authoring policies, applying proper policy as code, making sure there's unit tests. And again, all of the samples have unit tests, so you can start with that. But you can quickly get to writing your own custom policies and managing those.
And that's applying it against the local resources or a cluster?
You could do either, right? So in
Okay,
this
if I
case,
do-
these tests are applied in my case against a local resource, and I'll just quickly show what these tests look like. So, but it's up to you how you want to apply those. So these are my test cases, and I'm just saying which deployment, which policy, and what my expected result is. It's very simple to manage, and you can see there's a bunch of different test cases on the same policy of success, failure, and different combinations.
Cool. All right. Well, that was awesome. I learned a ton on the different ways you can use Kyverno, where it interacts with other tools, external and part of your CI/CD pipeline. So that was awesome. Thanks so much, Jim.
You're welcome. My pleasure.
Yeah, thank you very much, Jim.
If anyone else has questions and wants to follow up, where's the best place to kind of reach out and get help with Kyverno or getting started?
Yes, if you go to Kyverno.io, click on community, it has our Slack channels. Those are the easiest, and most of the maintainers hang out there. So we have a lot of end users in the community too. So just feel free to chime in on the Slack channels, or you can also on GitHub at just Kyverno, GitHub/Kyverno. Go ahead and you can file issues or just reach out over there as well.
Awesome. Well, thanks so much for coming on the show. Jimmy, thanks also for joining. This has been great.
Yep.
And everyone else, thanks for watching. We'll catch you next time.
All right. Take care. Bye-bye.